Hi everyone, and welcome back to our IGCSE Computer Science lecture series. Today's topic is Denary to binary conversion. In the last video, we established why computers use binary. Now we need to learn how to actually work with it. Converting a Denary number into binary is a skill that comes up directly in the exam, so we're going to go through it step by step until it feels natural. Now, the starting point is this place value table. Now, every binary number is made up of columns, each representing a power 2. Starting from the right here, we have 1, 2, 4, 8, 16, 32, 64, and 128. Each column is exactly double the one before it. So we have here 2, which is 2 times 1. We have, for example, here 16, which is 2 times 8, and so on and so forth. The column on the far right here is called the least significant bit, whereas this column here is called the most significant bit. Now, in order to convert a binary number into a denary number into binary, we follow this method with 4 steps. First of all, is we write out the place value table, which is this one here, and we use it for our reference in order to convert the number. We start from the left, which is the most significant bit here. And then if the place value fits in our remaining number, we write 1 and subtract. And if it does not fit, then we write 0 and we move to the right. So this might seem a bit vague, but let's start with a worked example in order to get a better and clear idea of how this works. So let's say we have the example of converting 75 to binary. What we do is we start with the place value table, which we have here, and then we go from the very left and start with the leftmost column, which is the most significant bit, and check if each of these numbers fits into our number that we want to convert. So does 128 fit into 75? No, it doesn't because it's bigger. So what we do is we write 0 and we continue on the right here. Does 64 fit into 75? It does. So what we do is we write 1 and we subtract 64 from 75, and then we get the remainder, and then we continue following this steps here. So does 32 fit into 11? No, it doesn't. So we write 0. We continue. Does 16 fit into 11? It doesn't again. Write 0. Continue. Does 8 fit into 11? Then it does. We write 1. We subtract 8 from 11, which is 3. And then we continue down this route until in the end we get 1, which is exactly equal to the place value in this rightmost column, and then we subtract it, which gives us a remainder of 0. In the end, our result is read from top to bottom. That means 75 is 0, 1, 0, 0, 1, 0, 1, 1. We can check another example to get a clearer idea. So in this case, we have the number 200, which we want to convert to binary. Again, we start with the place value table, and we start from the leftmost side. In this case, we have 128, which is actually smaller than 200. So we start by writing 1. We subtract 128, and then the remainder is used to kind of continue with the same process. 64 fits into 72. We write 1 again, subtract it. We have 8 here, and then we write zeros because the number is actually smaller than the values here until we get to 8, which is exactly what fits into this remainder. And what we do is we write 1, we subtract it, and now we have a case of a remainder which is 0. And what we do in these cases is we continue with writing 0 for each of these columns. And in the end, the number that we convert is 200 equals 1, 1, 0, 0, 1, 0, 0, 0. You did notice that once remainder hits 0, then all remaining columns are 0, and this is important to write and not miss, otherwise it could be the wrong number. Now, before we move on, I'd like to note 3 very common mistakes that students make in exams. First is forgetting to subtract. Now, every time you write a 1, you must subtract the column's value from the remainder. If you skip this step, every column after it will be wrong. The second one is working in the wrong direction. Always remember to start from the left, which is the largest column, and work to the right. So again, always start from the left and then move towards the right. And the third one is dropping leading zeros. Now, if the 128 column is not used in your answer, you still need to write a zero there. In the exam, an 8-bit binary number must always have 8 digits. A quick way, I'd say, to check your work is if you add up the place values where you wrote a 1, and once you get the total equal to the Denary number, you know for sure that you've converted that number correctly. So yeah, if the key takeaways for this video would be the place values for an 8-bit number are 128, 64, 32, 16, 8, 4, 2, and 1. I would suggest that you learn these as they come up constantly and they're very useful for when you're converting a denary number to binary. You must always remember to work from left to right. So remember the process that if the number fits, then you write a 1 and you subtract. If it does not, then you just write 0. And lastly is it's a really good practice that you check the number that you've converted is actually correct. And you do that by adding ones once like adding up to the original denary number. And in that way, you can ensure that your result is actually correct. Now, in the next video, we're going to do the reverse. We're going to talk about binary to denary conversion. And it is actually simpler. So it is actually simpler, but just as important for the exam. So see you there.